The first part of the opener, we have a chart that has fractions, decimals, percents. We're given one number in each row, and we want to convert it to the other ones. So let's start with this fraction, 6 over 8. If I want to convert this fraction into a decimal, what do I need to do? So to get that decimal, we're going to divide the fraction. What are we going to divide? What are we actually going to type into the calculator? 6 divided by 8, and the calculator gives us what? 0.75. Now, since I have work in this box, which I should have, remember, anytime you're using the calculator for something, you need to write down on your paper what you're putting into the calculator. Since we have work and a final answer, what should I do with my answer? Box it or circle it so that we know that that is the final answer. Okay. How about the percent? If I know the decimal, how do I change it to a percent?
Multiply by 100.
Multiply by 100. So again, I'm going to be doing some work to get this. We need to show how we're getting our answers. So I'm just going to put 0.75 times 100%, and that gives us 75%. And we'll box that because that's our final answer. All right, so remember, when we're doing these charts, you need to show how you're getting your answers, not just writing your answers in there. Now, there's one other thing I want to do with this row. I like our answer for decimal, I like our answer for percent, but I actually don't like our answer for the fraction. What's wrong with that?
It's not simplified.
It's not simplified. So remember, all fractions should be simplified as much as they can as the final answer. So even though this was the problem that was given to us, it was given to us as 6 over 8, we should simplify that since we can. What goes into 6 that also goes into 8? 2. So we're going to reduce this by 2, and we end up with what? 3 over 4. So we actually had to do a little bit of work for all 3 of them. Most of these problems, we're only going to have to find 2 of the numbers, but since that fraction wasn't simplified, we'll do that also. All right, next one we have the 36%. We want to change that to a fraction and to a decimal. It really doesn't matter which one we do first. I'll let you guys pick. Do you want to do the fraction first or the decimal first? Fraction? Okay, let's do the fraction first. 36% means 36 over 100. Percent means what? Out of 100. So 36% means 36 out of 100, and one way to write that is 36 over 100. Now that I have that fraction, though, what do I need to do with it? Simplify it. What goes into 36 that it goes into 100? 2. Remember, when we're doing these types of problems, changing between fractions, decimals, and percents, really the only way a fraction is going to reduce is either 2 or 5. All right, so we reduce by 2 here. 36 divided by 2 is? 18. And 100 divided by 2?
50.
Okay, can I reduce that? Yeah, reduce again by 2. 18 divided by 2 is?
9.
And 50 divided by 2.
25.
Can I reduce that?
No.
No. Okay, how about the decimal? We actually have 2 options for this. We could use the fraction that we just got to get the decimal, same way we did up here. We could do 9 divided by 25, or we could do 36 divided by 100 if we go all the way back to the beginning. Or if I wanted to use the percent to get the decimal, what would I do? Yeah, move the decimal 2 places to the... Moving the decimal 2 places to the left, or that's the same thing as doing what? Why do we move it 2 places to the left? What are we doing? It's like dividing by 100. Okay, so we're dividing by 100 here. So we either need to show that we're moving it 2 places to the left by doing this, or we could come over here and say 36% divided by 100% gives us what? 0.36. And again, make sure that you're showing the work. Show us how you're getting that answer. All right, last one. We have a decimal. We want to change it to a percent, and we want to change it to a fraction. Let's change it to a fraction, or let's go to a percent first. To go from a percent to a decimal, we divided by 100. So to go from a decimal to a percent, we're going to multiply by 100, which is the same thing as moving the decimal 2 places to the right. So we could either put 0.24 times 100, or just this right here is enough for the work for that. And we end up with what? Not 24%. 2.4%. It's a big difference between those two, so make sure you get that right. Okay, and that is our final answer for that one, so let's box that. The other way, this is a little trickier. We have 0.024 that we want to change to a fraction. So what am I going to have to do first for that fraction, to find the fraction? What do I need to know about the numbers in this? So we need to find the place value of the 4, the last digit in this number. What is the place value of that 4? That is the thousandths place, which means that what's going to be on the bottom? 1,000, right? And what goes on top? 24. So we take the number, but take the decimal off, and when we take the decimal off, we can also take those leading zeros off, so we get 24 over 1,000. Do we need to reduce that? Yeah. So let's try 2. 2 looks like it's going to work because they're both even. What do we get? 12 over 500. Can I reduce that? Yep. They're both even, so I'll reduce by 2. 12 divided by 2? 500 divided by 2? Can I reduce that? Yep. Let's keep going. Reduce by 2. 6 divided by 2? 250 divided by 2? Can I reduce that? No. Moving on to the back of the opener, we've got a couple of proportions that we want to solve. How do we solve a proportion like this when we have a variable in the proportion?
Cross multiply.
Cross multiply. So I always like to multiply the one with a variable first, but it really doesn't matter. So let's do 4 times a. What do we get? 4a. And then the other one we do 5 times 20 and get 100. Then what? Yep, we're going to solve for a now. So we circle a variable, draw the line, and then to get the a by itself, divide by 4. 4's cancel. We get a equals 25. The next one here is a little trickier. So when I cross multiply here the b minus 5 times 10, what am I going to need to do? Starts with a D. We need to distribute, right? So since we have the 10 times 2 different things, we have to distribute that 10 to both of them. So when I do this, I get 10 times b is 10b, but I also do 10 times negative 5, which is negative 50. Alright, then we multiply the other way. 2 times 15 is 30, and then we have our equation there. Don't forget to distribute when there's 2 different terms in the proportion. Okay, now we need to solve this like we normally do. So circle the variable, draw the line of equality, and to get b by itself, we're going to have to get rid of 2 things. What do we get rid of first? The 50. How do we get rid of the 50? Okay. 50's cancel on the left. That leaves 10b. And on the right side, 30 plus 50. Okay, then what? Divide by what? 10. 10's cancel on the left, leaves b equals 8. Last one here, we're going to have to set up a proportion to solve for this one. So we're given some information. On the test, I'll tell you right now, this is going to be in a section that says proportion word problem. So you're going to know what kind of problem it is. We're not going to make you try to figure it out. But you do need to do a few things when we have these word problems with proportions. The first is setting up a what?
Ratio of units.
Ratio of units. All right, so we're going to set up a ratio of units, which is just going to help us set up the rest of the problem. And this ratio of units is just going to be our comparison of 2 different units that are being compared in this problem. What types of units do we have in this problem? Okay, I see gallons and I see square feet. And what's this right here?
Square.
That's feet squared, which is the same thing as square feet, right? So a square foot, if you look at the tiles on the floor in here, those tiles are 1 foot wide and 1 foot
Square.
long. Yeah, so they're 1 foot square. So each tile is 1 square foot. So if you were to count the number of tiles on the floor, that would find the area of the floor, which would be in square feet. So we could say square feet like this, or we can write square feet like this, feet squared. Okay, they actually mean the exact same thing. So we have gallons and square feet. Does it matter which one I put on top in my ratio of units? No. So I'm going to put gallons first just because that was what came first in the problem. And then on the bottom I'm going to put square feet. Now that I have my ratio of units set up, now I can set up my ratios. So the first ratio is going to be comparing two things that we know go together. What two numbers in this problem do we know go together? So we know the 1 goes with the 350, so 1 gallon goes with 350 square feet because it takes that 1 gallon of paint to cover 350 square feet of area. So we know 1 goes with 350, and we also know that 1 goes on top because it's gallons, and that's what we put on top in our ratio of units. If you had square feet on top and gallons on the bottom, then you would be setting this up the other way. You would have 350 over 1. All right, so we have 1 gallon over 350 square feet. And then we're going to have another ratio that's going to include something that we're trying to figure out that we need to know. What's the other number that we do have, the other number that we do know? 2,450, and that is a number of square feet, right? That's the area that we want to paint. So where's that number going to go? So that goes on the bottom, and on top is going to be what? It says how much paint do we need, so we could call it a few different things. If we're looking for an amount of paint, we're going to be measuring it in gallons, so you might call it G. Since we're looking for an amount of paint, you might call it P. If you're the kind of person that just likes to use X for a variable for everything, then you could put X there. I'm going to go ahead and put P here for how much paint we're looking for. So then I can set these two equal to each other, and I have a proportion that I can solve just like the ones that we did up here. So to solve it like those other ones, we're going to cross multiply. We do 350 times P, which is 350P. And then we multiply 1 times 2,450. Type that into your calculator and get 2,450. You probably don't need a calculator for that, right? Because 1 times anything is the same thing. So we get 350 times P equals 2,450. And to solve, we circle a variable, draw the line of equality, and divide by 350 on each side. 350s cancel on the left, gets P equals 7. Should I box that? We're done? No, we're not quite done. What else do we need to do?
Gallons.
Yeah, we need to make sure we answer the question, and the answer to this question, the answer to these questions and these types of problems are always going to have units in them. Okay, we need to make sure we explain what that 7 is. It's not 7 square feet, it's 7 gallons. So to paint that much area, we're going to need 7 gallons of paint.